Hello everyone. I promised this video and expected to release it back in January, but it has proved to be just always out of reach. This was requested by Nihal Mirza, who asked about how to do multi-session processing with flat darks manually instead of using WBPP as I'd outlined in an earlier video. I've been trying to work on this, and it kept becoming overwhelming due to length and a desire to keep it focused and hopefully interesting without being insanely repetitive. Unfortunately, that's kind of what multi-session manual processing is by its very nature. I've stopped and started over about once a month, always to be unhappy with the result. Finally, I decided to focus on the workflow without getting caught up in the details. My hope is this will be the important bit for most people. And by not getting bogged down in the details of each process, we can focus on how this all fits together. So, Nihal, I hope this answers your question, assuming you haven't figured it out on your own by now. At the time of Nihal's request, one of WBPP's biggest shortcomings was multi-session processing. But shortly after that, WBPP 2.0 was released, and it handles multi-session processing wonderfully. With that being the case then, why bother with multi-session manual processing? Well, it's good to understand what WBPP is doing for us. Although most of the pre-processing steps are fairly mechanical, there are always opportunities for things to go wrong, and it's definitely easier to debug the process if it's well understood. Manual multi-session processing has a lot of steps, and it's easy to make a mistake, especially for mono-imagers who have to repeat all those steps for at least 3 filters. But we'll go through the process from beginning to end, and then we'll take a look at how straightforward it is in WBPP. Then you can decide what makes the most sense for you. Here are the assumptions I'm making before we begin. 1. You are using a mono camera. Everything I'm saying here applies to one-shot color, but in that case, you only have one set of images to deal with per session instead of 3 or more. You also need to add in a debayering step that the mono imagers won't need. 2. You're using a cooled camera and so can use one set of darks for all your calibration. If you're using a camera that isn't cooled and you take darks each night, then you'll need to do the steps to produce master darks each night instead of once. 3. You're taking flats each night. If you use the same set of flats for multiple nights, then you can group all of those nights together as a session. 4. You're using flat darks. If you're using bias frames, it would be similar but slightly different in the calibration steps. 5. You have data taken over 2 or more nights. 6. Each night you weed out the bad frames. See my video on subframe approval if you need to review this. 7. You are a masochist. We know this already because you're into astrophotography, but by going all manual, you are celebrating your masochism. Respect. Okay, with all of that out of the way, let's take a look at our project for this. This is an HA-RGB dataset of M101 that I acquired this year. We're not actually going to run through all the steps here. It would take too long, but we'll reference this project to put it all in context. Remember, nothing about this is specific to this filter combination. It's just as applicable to RGB, LRGB, narrowband, HA-RGB, one-shot color, or any other filter combination. For this project, we had 9 nights of acquisition. On each night, I acquired anywhere from 1 to 4 filters worth of data. Before we start, let's take a look at the overall workflow. Before we begin acquisition, we need to create our dark library if we haven't already done that. Fortunately, it is a straightforward thing to do manually. Then, each night, we have to do a set of calibration steps for each session. Finally, once we have collected all of the data, there are some final steps to produce our master light frames. First, we need to produce our master darks and master flat darks. To do that, we need to run the image integration process once for each dark and flat dark we need. If you are using bias frames instead of flat darks, a master bias is produced in exactly the same way as a master flat dark. In that case, just load up the image integration process with bias frames instead of flat dark frames. For this project, we have broadband frames with 60-second exposures and hydrogen alpha frames with 300-second exposures, so we need 2 master darks. And we have 4 different flat frame exposures, 1 for each filter used, red, green, blue, and H-alpha, so we need to produce 4 master flat darks. There's nothing really complicated about a flat dark. It is simply a dark frame used to calibrate a flat frame, just like a normal dark frame is used to calibrate a light frame. We could call those light darks. It's just convenient to call it a flat dark to specify exactly what it is being used for. If you have any confusion about this, see Adam Block's excellent video that goes into the theory of calibration in detail. His explanations are clear and thorough, and he does a better job of explaining it than anyone I've seen. I'll leave a link in the show notes. This is where things get complicated, or at least very fiddly. Each morning, we have to run through this for each filter. If you save up several nights to do together, then it becomes fairly easy to make a mistake. If you do it each morning, then it generally isn't too bad, especially if you only acquire 1 or 2 filters per night. First, we need to produce our master flats for the session. Each morning, we have to run through this for each filter. If you save up several nights to do together, then it becomes fairly easy to make a mistake. If you do it each morning, then it generally isn't too bad, especially if you only acquire 1 or 2 filters per night. To do that, we'll use the image calibration process for the flats. Load up the flats, and then specify the master dark that we produced for this flat exposure. You know, that thing that we called a flat dark. Specify the output directory and run it, and we'll get back the calibrated flats. Next, we'll integrate those calibrated flats to produce a master flat. Then, we need to blink our lights looking for obvious problems like clouds or doubled stars. Once those are weeded out, then use subframe selector to do more quantitative approval of frames. For the details of this process, see my video on subframe approval. Once subframe selector is done, then we can calibrate the lights. We'll use the image calibration process again, and for each filter we need to specify the master dark for that filter along with the master flat for that filter. When it's done, we have one more thing left to do, cosmetic correction. Loading your files, check the Use Auto Detect checkbox. I used 3.0 for both high and low, and that seems to work well. Again, specify an output directory and run the process. We now have a set of calibrated lights for 1 filter's worth of data for 1 session. Copy those cosmetically corrected files to a holding directory where we're going to collect all the files for all the sessions until we're ready to do the final integration. Now we have to do this again for each filter for that session. Then we have to repeat this set of steps for each subsequent session, again for each filter used in that session. For this particular project, I had 9 sessions. The first session had 2 filters, the second had 3, the third had 3, and so on. It's easy to make a mistake here, so be careful and double check your work. You can help by making a process icon for each filter step that already has the appropriate master flats and master darks selected, but you'll likely need to change output directories and load in the correct set of images. It's easy, really easy to lose track, and there's nothing to warn you that you have done something wrong. PixInsight will blithely follow your instructions, assuming that you know what you're doing. Even if you do know what you're doing, you likely haven't had as much sleep as you need, and it's easy to do the wrong thing and produce a bad result. Double check your settings. If you're me, triple check your settings. So my video on PixInsight preprocessing with flat darks is a reasonable starting point for the details of what you're doing here. It basically covers what you're going to do in 1 session. It doesn't talk about approval, but the video on subframe approval goes into the detail on that. If you combine those two, you get the gist of what goes on in this section. Eventually, we'll reach a point where we either have all the data we intended, or we can no longer get any for the current season. Or, as a former manager might like to say, it's time to shoot the engineer and ship the product. I wonder if the COVID restrictions on visiting prison inmates have been lifted. I haven't seen him in a while. But seriously, at some point, you're going to want to produce some master lights. The first thing to do is to run subframe selector, and this time we're going to clear out the approval expressions and concentrate on the weighting expressions. Now that we have all of our subframes, we can properly weight them, something we couldn't do earlier because you can't generate correct weights until you have the full set of data. If you're using one-shot color, you need to debayer now. Finally, we load our images into star alignment and select an output directory and a reference image. I tend to pick the image from subframe selector that has the highest weight, but you might prefer to use the one with the smallest FWHM. I almost always use default values for everything else. Finally, we get to do image integration. Run image integration and inspect the final image and the rejection maps to see how things look. Now do all of this again for each filter that you have data. Congratulations! You have processed multi-session data and you have a better understanding of the pre-processing process. If you're like me, you'll never want to do it again. Now, let's look at a kinder, gentler solution. WBPP 2.0. This is the workflow to use if you want to calibrate each night's images and then do final integration when acquisition is complete. I'm not going to go into huge detail here because this video is about workflow rather than detailed process settings, and because Adam Block's definitive guide to WBPP 2.0 is a fantastic resource. Go watch those videos if you really want to learn the tool. The blink and subframe selector steps are exactly as we did for manual pre-processing. The purpose is to eliminate any bad frames. Once we have approved frames, we can load the approved frames for each session into WBPP and do everything in one step up to and including master light integration if we want. The experts recommend that you do star alignment and image integration separately, and there are good arguments for that, especially for image integration. But if you aren't going to do anything complicated in your integration, and you aren't going to fiddle with rejection parameters, then why not just do it in WBPP? You can always run another integration later if you want to. To make this work, there are two things we need to do. The first is to name our directories for each session in a way that WBPP can semantically understand them. I name my directories session-01, session-02, and so on. Then, in WBPP, add a grouping keyword called session, and it will handle all the mapping of darks, flats, and lights for you. And it will let you check your work so you can ensure that files will be calibrated as you expect. I think this is at least as important as the addition of the multi-session support is. In many ways, PixInsight exemplifies the garbage in, garbage out philosophy. It's up to you to make sure you are using the tool properly, but in this case, WBPP gives you at least some help to know that you're calibrating correctly, and that makes this tool extremely worthwhile for me. This looks very similar to the last workflow. The only real difference is that we are saving all the blinking and approval until the very end. Since those steps don't have any dependency on master darks or master flats, we could, if we want, save all of it until the end. It might get a little bit tricky ensuring that all the light files end up back in the right session directory as we described earlier, but you could fix this by having your acquisition software write a file name with session-01 and so on into the file names. WBP should pick it up from there instead of the directory name, and then you don't care about the directory structure as much. I tend to use workflow A, but workflow B is equally valid. The great thing about WBPP is that the control panel shows you which flats and which darks get used by which lights. Unlike the manual process, it helps you make sure that the files get matched up properly, which is a huge help. It only goes so far though. It doesn't pay attention to gain, offset, or temperature, so it still would be possible to use the wrong temperature darks, for example, And so long as the time matched, WBPP would be happy, but the result would be wrong. So depending on exactly how much data you have to process, you can either grab a fine beverage, eat a meal, watch a movie, maybe take a complete course in modern astrophysics. Exactly how long WBPP will take depends on the amount of data and the speed of your computer. But the good part is that however long it takes, you don't need to babysit it. You don't have to worry about getting confused about which directory you're working in and which output directory you should use for which step. Whether it takes 5 minutes or 5 hours or even 5 days, you're free to enjoy those days, hours, or minutes as you see fit. Whenever WBPP is finished, you can open the master lights it created and inspect the lights along with the rejection maps. WBPP also produces a detailed log file that can be useful if it looks like something went wrong. For me, the control panel in WBPP makes it an easy decision to dump manual processing, at least for everything up through star alignment. And unless I'm going to do something more complex like local normalization, something I don't normally do, I've found that I can let WBPP produce my master lights for me. I don't doubt that a more knowledgeable user could optimize rejection parameters, but I'm at least as likely to hurt my image quality as help it, so I keep myself out of the loop there, at least for now. If I learn more in the future, I may change my mind. Nihao, I'm sorry this took so long to produce. This is a detailed and complicated topic, and I'm hoping that going over workflow is something that people will find useful. When I tried to combine workflow info with all the detailed steps, I found myself constantly making mistakes. It's actually, for me at least, a good argument to avoid manual calibration. It's super easy to make mistakes, especially when you're doing multiple sessions, one right after the other. I hope that by concentrating on workflow, this will help guide people in the right direction. I'll include links to other videos that supplement this that you may find helpful. Until the next time, clear skies.